Hey, how's it going? It's Mr. Farrell here with a quick video tutorial on calculating the thermal heat energy, okay? So the problem we're gonna work on today is asking us how much energy is needed to lower the temperature of 4 kilograms of water from 40 degrees Celsius to 20 degrees Celsius, okay? So we're going to start this problem as always with our ICE method, okay? So that is I-C-E-E, okay? The I stands for identify, C categorize, E equate, and the last E evaluate. So first we're gonna identify all of the measurements in our problem, okay? So when we look at this problem, we see any number attached to a unit is a measurement. So we've got 4 kilograms, 40 degrees Celsius, and 20 degrees Celsius. So those are all of the measurements we see in this problem. So we're gonna go ahead and write that down. 4 kilograms, 40 degrees Celsius, and 20 degrees Celsius, okay? Now, in the identify step, we also wanna acknowledge that there is a question being asked of us. And it is certainly asking us a question because there's a question mark, but we don't yet know what that question is. So we're gonna have to figure that out. But I always like to put a question mark there just to remind us to make sure we know what we're looking for, okay? But we're gonna figure that out in our next step, which is our categorize step. So once we've identified all of our measurements and we know that there's a question being asked of us, we need to categorize those things. We need to figure out what is 4 kilograms, right? What variable represents that? What is 40 degrees Celsius, 20 degrees Celsius? And then what variable represents the question that we're looking for, okay? So we're gonna go ahead, I like to draw some down arrows here. So 4 kilograms is mass, okay? We can tell from kilograms is a unit of mass. 40 degrees Celsius is going to be a temperature. We represent that with an uppercase T. 20 degrees Celsius is also gonna be a temperature. Again, represented with an uppercase T. Now, when it comes to the question we're being asked, this one takes a little bit more brain work on our part. So the question is asking us how much energy is needed, okay? Now there are a couple of different ways we can measure energy. You could think about energy in terms of kinetic energy, so that's energy of movement or motion. You could think about energy that is used to do something or work, okay? Or you could think about energy that is related to temperature change, thermal energy. So as you can see, there are multiple different things we can think about when we think of energy, but this energy is thermal energy. Now we know that because this energy is dealing with a temperature change, so that is related to thermal energy, but you can also use process of elimination. So we wouldn't use kinetic energy because this energy is not the energy of a moving object, okay? We also would not use work energy because we're not saying that this energy is used to do something or to do work, okay? So we are left with thermal energy, and we represent thermal energy with the variable Q, okay? So we're gonna put Q right there. All right, now, this looks pretty good. We've got all the variables that go with the different measurements we identified. But we also have an issue here because we say 40 degrees Celsius is T and 20 degrees Celsius is T. Now these can both be temperatures, but they can't both be the same variable. They need to be distinguished somehow. So we're going to make one of these T1 and the other is going to be T2. Now T1 is going to be our starting temperature, T2 is our ending temperature. In order to figure out which one is which, we're going to read our problem again. Now our problem says, how much energy is needed to lower the temperature of 4 kilograms of water from 40 degrees Celsius to 20 degrees Celsius? So we are lowering our temperature from 40 degrees Celsius to 20 degrees Celsius. So we're starting at 40 degrees Celsius and moving down to 20 degrees Celsius. So we're going to label 40 degrees Celsius as our T1 and 20 degrees Celsius as our T2. And again, that's because we're starting from 40 and we're going to 20, okay? Now we've got everything labeled so we can go ahead and choose our equation. Now, when we're calculating energy and heat energy, there's one equation that jumps out and comes to mind, and that is the specific heat capacity equation. So that is going to be M times delta T times the specific heat capacity of the material, Cp, equals our thermal energy. Okay, now M is the mass of the material, all right? Delta T is how much that material changes temperature. And then C sub P is the specific heat capacity. So how much energy does it take to heat up that material by 1 degree Celsius, or changes temperature by 1 degree Celsius, or 1 Kelvin, okay? And then Q again is our thermal energy. Now let's go ahead and plug in our measurements so we can solve this problem. So our mass, which is given, right, we say it was 4 kilograms. Our delta T, all right, so our change in temperature is going to be T2 minus T1, okay? Anytime you see delta T, that can be rewritten as T2 minus T1. So we're going to write delta T here by plugging in our numbers. Now our T2 is 20 degrees Celsius, so that's going to be T2 minus T1, which is 40 degrees Celsius. Okay. So we've got mass, delta T, and now let's go ahead and write our specific heat capacity. Now, we need the specific heat capacity of the material that's changing temperature in this problem. And if we read the problem, it tells us that 4 kilograms of water is changing temperature. So the specific heat capacity we're going to need is the specific heat capacity of water. That you can look up, and the one we're going to use is 4,186 joules per kilogram times degrees Celsius. All right. Now, sometimes you may see this written as joule divided by kilogram Kelvin, which works. But in this case, we're using Celsius because our change in temperature has been measured in Celsius, not Kelvin. Okay? So we're going to go ahead and solve this problem for Q. All right? And let's go ahead and answer this or solve this by using PEMDAS, or please excuse my dear Aunt Sally. So we're going to do parentheses first. In this parentheses, we see that there is an operation that needs to be done, so we'll do that. So this will be 4 kilograms times 20 degrees Celsius minus 40 degrees Celsius. That is going to be a negative 20 degrees Celsius. And then we're going to multiply that again by 4,186 joules over kilogram times degrees Celsius. All right, and that's going to give us our measurement of heat. All right, so let's go ahead. Now that we've done parentheses, we don't have any exponents, and so we can go into multiplication and just multiply 4 times negative 20 times 4,186 in order to find our answer. So let's go ahead and do that. All right, now when we calculate our final answer, we're going to get negative 334,880. Okay, now let's go ahead and figure out our units for this number. So if we look at our 4 kilograms here, this kilograms is actually going to cancel out with the kilograms down here in the numerator. Now this degrees Celsius in the denominator down there. This degrees Celsius in the numerator is going to cancel out with this degrees Celsius down here in the denominator. And we're going to be left with a unit of joules in our numerator. Okay, so let's go ahead and write this here. Joules equals Q. Okay, so let's go ahead and box this out. All right, and that's our final answer. Now let's go ahead and talk again about what this answer means. So the fact that our answer is negative is telling us that energy is leaving our system, okay? Which makes sense, right? Because if our water is lowering its temperature, is getting colder, then it needs to actually release energy from itself, okay? So the system of our water needs to lose energy in order to decrease its temperature, All right, so if energy is being lost, it is leaving the system, which means it is going to be negative. All right, now if the water was getting warmer, if it was getting hotter, then we would need to add energy to our system, which means our energy would then need to be positive. Okay, but in this case, the negative sign makes sense. All right. And let's see, a couple other things to see, right? Just noticing again, the specific heat capacity of water. If this was a different material, if it was aluminum or iron, right, it would have a different specific heat capacity because it takes less energy to heat up iron than it does water, or takes less energy to heat up aluminum than it does water. So depending on what material you have, you may or may need more energy, or you may need less energy, right, in order to have the same resulting temperature change. All right, sweet. So glad y'all were able to join me for this problem. Hope this helps you work through other math problems in the future, or physics problems. Have a great one.